So today we are going to study the electrical and physical quantity analogous system. As we know that in our daily life, the two systems are always going with us. If we move anything that is mechanical, if we want to move something, then it is electrical. Such as if we want to use motor itself is mechanical device, but when it's connect with the electricity, then produce some works, then that is, we consider that is the electrical component, right? So what is the electrical system we need to have for controlling the device or operating the device. Such as we can operate any device manually, we can operate any device automatically. Understand? So these two things has a good relation, and by those two things, your engineer can control the things. And the major thing is of this topic is the modeling the system, modeling the physical system like AutoCAD or the any kind of physical system. If you want to control, then you need to model. For modeling the purpose, then we apply this analogous system. Understand? So we have two types of analogous system. One is called force voltage and the force current. Two types of analogous system. So force voltage here, what you can see on the slide, that is force voltage analogy system. So by definition, it says the analogous is an representation between mechanical and electrical system. So in first slide of analogous system, it has definition, then the relationship between mechanical element and electrical elements, and then their energy equation. And from this slide, you will be known that if you want to convert any physical system into a electrical circuit, it is possible. It is possible by following this voltage force analogy system. Another analogy also available, that is called current force analogy. But voltage force is easy to understand. I will explain why it is easy. Then you will feel that yes, this is easier than current force analogy. And voltage force analogy is similar to, you have studied the physics. It's almost similar, and it has a good logic also. That's why I have picked this analogy system. Any analogy can be applied to convert mechanical elements to electrical elements. There's no problem, all right? Or vice versa. So the objective of this topic is to requirements of some cases, modeling, testing, and controlling. So as I mentioned earlier, that this analogy is used for modeling a system. Actually. After modeling, we do control and then testing. That's the purpose of this topic. So if I give you one example that you want to control a electric vehicle, right? Or any vehicle, then you have to get some information to control, right? Like microcontroller. In microcontroller, what you do? You give input, you make a program, then according to the program, it passes the output. And that output hits your target element. And then it's operate. This is the overall control or testing system of electric vehicle.
Sir, in car, it is ECU.
What?
ECU, sir. Electrical circuit where we can control the mechanical component of car.
Yes. You see the battery, there is a battery. Battery is the electrical component in a vehicle, right?
Yes, sir.
So from that battery, we generate the energy and that run the electric vehicle. How? Because of control, all the mechanical parts, all mechanical parts convert into a circuit, and then which element are converting from what? By that element, we are controlling which point, then engineer all calculation analysis, and then find out this is the point, component or element that should be considered to control this part.
Yes, sir.
So here we can see the table. Inductor equivalents to mass. Resistor equivalent to friction. Capacitor equivalent to spring constant. Voltage equivalent to force. Current equivalent to velocity. Charge equivalent to displacement. Now you look why they are equivalent. Think their background, why it is. Mass. Everybody remember mass, right? Every substance has mass.
Yes, sir.
Right? So in case of mass, then what they do? They have itself energy, right?
Yes, sir.
Now you think inductor. Inductor has inductance. What they do? Inductance protest acts as an AC resistance, as well as it can store energy, right?
Yes.
Isn't it?
Yes, sir.
Yes, sir.
Now you think resistor. Resistor is a loss, consume the energy. As I mentioned yesterday, resistor consume energy. That means create the loss,
Yes, sir.
right? And it also produce heat. I square RT, Joule's law. I square RT, Joule's law, that based on resistance. So for friction, it also generate heats. It's also create the loss of energy. If you don't believe, you can do yourself the movie, rubbing your hands, 2 hands rub. Okay, 2 hands
Yes.
rub, you will see there are some heat you can feel. You can feel some heats between
Yes,
2 hands. Understand why
Yes,
it
sir.
is happening? Because
Yes, sir.
the hands feeling resistance between them, and they move. When they move, it generates heat. So the friction or viscous damper is equivalent to resistor. Now you may confuse with the viscous damper. Viscous damper is a kind of piston which has the elasticity huge. That's why it protests to move. Resistor also, the resist the moving the current, right? So they are characteristic similar. That's why they are equivalent. Now capacitor store energy by saving charge.
Yes.
Spring constant. Everybody knows spring.
Yes,
If
sir.
you expand, it protests.
Sir,
Right?
viscous damper. Can you repeat it again?
Viscous damper is a kind of piston. Piston,
Yes,
do
sir.
you know piston? The something
Yes, sir.
ups and down. It's like the either football pumper or bicycle pumper. Huh? When you
Okay, sir.
pump up,
Sir.
then is back force coming and creates the heat and resist the system. Understand?
Yes,
So
sir, I understand.
in case of spring, then you can see the spring can expand up to its strength. Capacitor can save energy up to its capacitance value, right? So they have the relation, similar relation, characteristic relation. Now voltage is force. Voltage, what is voltage? Electromotive force is the voltage, right?
Yes, sir.
Electromotive force is the voltage. Also, we can call another thing that the potential difference between 2 points also we call voltage, right? But
Yes.
here the voltage is the source voltage, which is electromotive force. So electromotive force equivalent to mechanical force, F. F is a MA. M is the mass and A is the acceleration. Force is MA. So in case of voltage, same thing going to happen.
Equal.
Yes, sir.
Current. What is current? Movement of charge per second is the current, right?
To follow electron.
Movement of electrons, sir.
Rate of balancing.
Electron,
Balancing
flow of
electron.
electron, yes, flow of electron.
Flow of electron with
With
respect
respect
to
to
current,
time, right?
time.
The
Yes, sir.
electron is a charge.
Yes.
Electron is a charge
Yes.
particle,
Yes, sir.
right? So that's why charge.
Yes, sir.
Clear?
Yes, sir.
Yes.
Yes, sir.
That means
sir.
dq by dt is the current. Q is the charge and t is the time. So dq by dt is the current. Now you think velocity. What is velocity? Velocity defines that the movement or displacement per hour, right? Per hour or per second is the velocity.
Yes, sir.
That means dx by dt.
Yes.
dx by dt, velocity.
Yes. ds by
And
dt.
current, dq
Yes, sir.
by dt.
dt.
Understand?
Yes, sir.
Clear? Now charge equivalent to displacement. If you see voltage and current relationship, you can find out easily here charge is equivalent to displacement. Charge is moving particle, right? Displacement also some movement. Huh? Understand? Distance, displacement is distance. Okay.
Okay, sir.
Any question about the table? Because it is very important to understand their equivalent relationship. So I consider everybody understand clearly. Now
Yes, sir.
you think that their energy relationship. Inductor energy relation is energy equation is
Sir,
half
repeat again.
Li square.
The table.
Again, you need to know the table. Where? Which part? I said charge equivalent to displacement because charge. Have you seen the charge particle in a electronics? One.
The capacitor.
A capacitor unit, capacitor. Okay, capacitor. Capacitor has capacitance, right? That
Yes, sir.
capacitance keeps the charge inside the capacitor, right? Coulomb. Coulomb depends on voltage and capacitance. Q equals to CV, right? So the charge
Yes, sir.
equals to capacitance into voltage.
Yes, sir.
Understand? So capacitor is stored the charge, that means energy, charge,
Yes, sir.
energy. So in spring constant, it can also store the charge. How can you realize? You see, when you wants to expand the spring, it protests, right? That means itself has potential energy. Understand? If you look at the bottom line, there is a spring potential
sir.
energy. Half,
Yes,
what is that? Half kx square. That is the potential. There are two types of energy: potential energy. Another one is kinetic energy. Energy which gives the energy itself. When
Sir,
it wants to
here-
move, it does not want to move.
Sir, here K is denoted by sir here K is sir kinetic energy. 1 by K.
Kx square. Or 1 by k, no. 1 by k is the spring constant. Is equivalent to C. C, capacitance equivalent to 1 by k.
Sir, here K is equal to kinetic energy.
K is a
Or, sir,
constant. No. K is not kinetic energy. K is a constant value.
Sir, here another thing, sir. Capacitor makes store imbalance charge, and spring also, sir, makes the object store the balance, sir.
Okay, I think, yes, the spring can do that thing. What do you mention? Spring can, capacitor also can. So their characteristic you need to know. Don't confuse with the K. K is a constant value, remember. K is not the kinetic energy. Kinetic energy is different thing. Kinetic energy, if you go half mv square, that is the mass kinetic energy.
Yes, sir.
Now their energy equation, if you look at the inductor magnetic field, inductor works based on magnetomotive force. Okay, so based on magnetomotive force, the surrounding their magnetic field create and current passing through the conductor, right? So based on that inductance and current, they have the what is called that energy equation. That equation is half Li square. Any inductor, small, big, or whatever size is that matter. Their energy depends on inductance and current flow through the inductor. The current flow through the inductor. That's the thing. And second one is the half mv square. Everybody knows it, right? Half mv square from the physics.
Yes, sir.
Yes, sir.
Yes, sir.
So they have the good equivalent form. Similarly, capacitor electric field energy, half CV square. In this case,
Yes,
the
sir.
spring potential energy, half kx square. Okay.
Yes, sir.
So don't be confused with the C is K. No, C is equal to 1 by K. C is equals to 1 by K. All right. But in potential energy, half kx square. So if you want to consider the x, B, here B is force, but in potential energy, x is the displacement. So you need to convert this part. Yeah, like B is C by Q, right?
Yes, sir.
Isn't it?
No, sir.
What?
Again,
Q
sir.
equals to CV. So B equals to Q by C.
Yes, sir.
So you can replace that one, then you can find it this. All right?
Okay, sir.
Try this one by yourself. This is your task. this in second slide, it is found that the elements, circuit elements, equivalency and their voltage and force relationship. So from this slide, you can understand that resistive voltage drop equals to resistance multiplied with the flowing current, right? So in case of viscous damper, as I mentioned, the viscous damper is a piston, you see, piston ups and downs. So here you can see the piston itself has some constant, that is B, damping constant, and moving velocity. Here the relation, you see the IR is here is V, velocity. Don't confuse that it is voltage. No, it is velocity. Similarly, VL equals to L dIL by dt. FM, the mass force, equals to MA. Remember MA, right? A is the acceleration. A is the d velocity divided by dt. So in case of capacitor voltage, 1 by C integration of IC dt. Here in case of spring force is equals to K integration of V dt. Understand?
Yes, sir.
Yes, any question? I think no question, right? We are going to convert electrical circuit to mechanical analogous system. Here, this is a RC circuit, which is first order circuit, right? So we need to find out their analogous. That analogous can define their transfer function itself. Okay. So in the left side, it has been shown the RC circuit and their transfer function. Right side shows the analogous of RC circuit and its transfer function. All right. So transfer function, we need to always find out because it defines the output and input relationship in this topic. But transfer function can be different. It depends on case to case. What do you want to control? If you want to control output, then output by input. If you want to control some part of the current, then some part of the current divided by input current. So you can find out the transfer function. And remember, transfer function is not the efficiency. Somebody may think, okay, V out, V in, it may be input, no efficiency. No, not like that. So don't confuse with the transfer function and efficiency, totally different. Efficiency also has relation with the power, but transfer function has no relation with the power. It's voltage and current or its parameter. Now let's see the RC circuit, how RC circuit being used here to find out the transfer function. V in equals to VR plus VC, right? By applying KVL, we found this equation. Now V in equals to R IC plus VC. Why we keep VC? Because VC is the output voltage, because we are taking voltage from the VC, because this is output side. Okay, so that VC we keep it constant. After that IC, because since it is a series circuit, then IC equals to what?
Capacitor current.
C dVC by dt. C dVC by dt. IC equals to. Everybody remember this relationship?
Yes.
It was discussed maybe in first class or second class that IC, IL, BC, VL, that equation already have been taught. So here we replace just IC. Then we found that VC is V out plus IC d V out by dt. Now d by dt consider capital D, then V in equals to V out plus RC d V out. So if we take out the V out component, then it is coming V in equals to V out 1 plus RCD. Then V out divided by V in equals to 1 over 1 plus RCD. What is RC? Can you remember what is RC? Sharifur Rahman, what is RC? Sharifur, are you there here in the class or you left?
Sorry, yes, sir. Sir.
Okay, what is RC? You did not. RC is the time constant of RC circuit. You forget, RC is the time constant. All right. So everybody understand this left part, RC circuit analysis?
Yes, sir.
Yes, sir.
Okay. Now we are moving to in the right side. What is the analogous of RC circuit? Resistance equivalent to damping, right? Damper, viscous damper, and capacitor equivalent to spring. Now, how they are connected? Are they connected in series or parallel? How they are connected? That is a big question. In case of series circuit, what is common? What is constant? Current, right?
Yes, sir.
In series circuit, current is constant, same every time, everywhere. So we need to think then how this would be connected. Is it series or parallel? If we connect this viscous damper and spring series in series, then which one? Any component will be hit firstly. After it's done, then another will move, right? But if we connect in parallel, they'll have same velocity and same time. Isn't it?
Yes,
Here
sir.
is the velocity meter, right side. Velocity should be same. So we have considered that they are connected in parallel. So if viscous damper piston ups and downs, same way the spring will expand and squeeze. All right. So from that left side equation, you can follow similarly. Input force equals to damping force plus spring force. All right. Damping force plus spring force. Then damping force equals to BV and spring force is Kx. Then you change this one inside the velocity, you know. So B 1 over K d F out divided by dt.
Sir, here B is equal to what, sir, and V is equal to what?
Okay, B is the damper constant, which is equivalent to resistance. Okay, and V is the velocity, which is equivalent to current, and X is the displacement. All right, so how much is move or expand or compulsion occurs. Compression occurs.
Okay.
After that velocity is changed to 1 over k df out by dt. df out by dt. So similarly, you can follow this one. Left side r c d v c by dt is similar construction of the equations. Okay, the same way you are taking out f out from the one what is called the above equation, that f in equals to f out multiply with the 1 plus b by kd. So f out by f in equals to 1 over 1 plus b by kd. This is the transfer function of this spring damper analogy. Okay. Any confusion? No, I think so, because this is very easy. Now RL circuit, left side RL circuit and right side the mass damper analogy. Same way we applied in series circuit, since it is a series circuit, but important is location. Here has used the inductor, but we are taking voltage across the resistance. Okay. No one should write R is with the source and inductor is the output side. Then the circuit will not work. Understand? So Vn equals to Vr plus Vl. Then Vin equals to Vr is out, V out, and LdI by dt. Say I is how much? Since it is a series circuit, so we can write down Vr by Vr. So Vr equals to V out. So we are having the similar relationship now like previous slide. That Vn equals to V out plus L by R, d V out by dt. Then V out has been taken out with the multiply 1 plus L by Rd. Then V out by Vn equals to 1 over 1 plus L by Rd. L by Rd. Okay. So what is L by R? Anyone can answer? What is L by R in this circuit?
Time constant of RL circuit.
Time constant.
Exactly. Thank you. Thank you. Now we are moving to right side part, that is the mass damper analogous. It is like similar way we have derived, since it is the parallel combination of mass and viscous damper. We have followed the similar way. So if you compare with the transfer function, you can find out the similar relation. Like here has in RL circuit, it is written 1 over 1 plus L by Rd. But in case of mass damper, 1 by 1 plus L by B, M by B, D. So M equivalent to L, R equivalent to B. So they have the good combination, right? Good relation. Now your task will be find out the transfer function of RLC series circuit and draw the analogous system and derive its transfer function. This is your homework assignment.